All right. So basically, the main thing here that you should understand is that if x minus a is a factor of a polynomial, then the polynomial has a value 0 for when x equals a. So that is the factor is how we find the 0. Does that make sense? And then graphically, that 0 represents the x-intercept. Yeah? You agree with that? Okay. So
A is y and x equals a is 0. Not y. A is x.
A is your x-intercept. When you solve that, it becomes your x-intercept. Okay, so techniques we've learned so far. Factoring out the GCF. Agreed? Okay. Quadratic trinomial. So product of AC, sum of B. Whether it's mental or Xbox. Perfect square trinomials. Difference of squares. Quadratic formula. All seems familiar? Yes? Agreed? All right. So keeping that knowledge in mind, we're going to start with part A. Part A is solving polynomial equations using factors. So there are two types of solutions, real and imaginaries, right? So we have real solution and imaginary solutions. Real solutions can be seen graphically as x-intercepts. Imaginary solutions are calculated typically using the quadratic formula. Okay. So when we're talking about graphically, if we have a real solution, that means I see when that graph crosses the x-axis, right? These are real solutions. My imaginary solutions mean that my graph doesn't ever touch the x-axis. No, its solutions are imaginary. They're floating. They do not cross the x-axis. Okay, that's why you can't just look at a graph and calculate the imaginary solution. Make sense? All right. So steps to solve. Step 1 is to move all terms to one side so that the equation equals 0. Step 2, we add, subtract, and multiply to combine like terms. Hence why your quiz today, 8.2, is reminding you how to add, subtract, and multiply and combine like terms. Oh my God. Okay. Then step 3, we're going to use our previous factoring techniques and then set each factor equal to 0 and solve. Again, using our zero product property. If the trinomial cannot be factored, use the quadratic formula to solve. Remember, that's our catch-all. Quadratic formula is our catch-all. Okay, so we're going to start at x to the 4th equals 16. If you're in class taking notes on your paper, I'm going to apologize. I have no clue why I made that box so small. Well, you're not going to have enough room to fit the work in there. I apologize again. So we have x to the 4th equals 16. Step 1 says to move all terms to one side so that one side equals 0. So step 1, I have to subtract the 16. So I'm left with x to the 4th minus 16 equals 0. Step 2 is to add, subtract, and multiply to combine like terms. Well, step 2 is good to go, right? Like terms are good. Step 3 is to use my previous factoring techniques. So looking at this, I noticed that, oh, interesting. There are x to the 4th and 16 are being subtracted, and they are perfect squares. Well, I did learn a previous factoring technique. That's the difference of two squares. That's dots. So difference of two squares. If we look at on our recall, that means that if I have a squared minus b squared, it's going to equal, it factors out to be a minus b times a plus b. So in step 3, when I'm factoring this, I'm going to use dots. I'm using difference of two squares. So I take the square root of the first term, square root of the second term. What's the square root of x to the 4? What's the square root of 16? 4. So that's my first factor, and my second factor is its opposite, plus 4. Okay, I look here, I have x squared minus 4 times x squared plus 4. I now have my factors, and step 4 tells me to do what? To set each factor equal to 0. So I have x squared minus 4 equals 0, and I have x squared plus 4 equals 0. So I add 4, and I get x squared equals 4. I take the square root. So x equals positive 2 and negative 2.
So we're just simplifying it all the way down.
You're solving. Yeah, you're solving. All right, plus 4. I'm going to subtract 4. That leaves me with x squared equals negative 4. Take the square root. What happens when I take the square root of a negative? It produces a what? Yeah. It produces imaginaries, that I. So we end up with not just 2, but 2i and negative 2i. So between my real and my imaginary solutions, they should equal the degree of my polynomial. What was the degree of my polynomial? 4. And how many total solutions do I have? 4. Do we see that? So the degree of my polynomial and the number of real and imaginary solutions should be equal. And that's even if they have multiplicity. All right, how do we feel? And again, I apologize for the little box if you're using the paper. I have no clue what I was saying. Okay, next example. There's a variety of things that you have to factor, but the 4 steps remain the same. Just how you end it is what's going to be different. Step 1 is make sure one side is equal to 0. So to begin, for step 1, we're going to subtract our 3x. So that leaves us with 2x to the third minus 5x squared minus 3x equals 0. Step 2 is to make sure that all like terms are combined. All like terms are combined. And then step 3 is where we use our previous knowledge of factoring. So first thing I should do based on previous knowledge of factoring here is what? Take out an x. So take out my GCF, right? My GCF is x. So I factor out x. And I'm left with 2x squared minus 5x minus 3 equals 0. Okay, now I just have a quadratic trinomial. So factoring this quadratic trinomial, I have a couple options. I have the X box, I have grouping, and I have the quadratic formula. You pick your poison. I'm going to do X box. So X box is saying your A times your C is negative 6, and it needs to equal my B, which is negative 5. So what two numbers multiply to give me negative 6, but add to give me negative 5? Negative 3 and negative 2 give me positive 6, because the negative times a negative is a positive. How about negative 6? Negative 6 and 1. Okay? So from here, you have the choice to either do the X box or you have the choice to do grouping. I'm going to go old school with grouping here. So we have X times 2x squared minus 6x plus 1 minus 3 equals 0. All I did was replace negative 5x with an equivalent expression. Just like the box, when you're in grouping, all you're doing is finding GCFs. So the GCF here, GCF here. So again, X is hanging out because it's still part of the party. Just because you get factored out, are you kicked out the family? No, you just don't live in the house. So the GCF here is 2x, that leaves me with x minus 3. The GCF here is just 1, that leaves me with x minus 3. The GCF here, so we have x. And my GCF between these two terms is x minus 3. And that leaves me with 2x and 1. So now I have fully factored. I have no clue why I'm going sideways. So step 3 is complete. Step 4 is to take each factor and set it equal to 0. So we have x equals 0. Oh, that was so tough to solve. We have x minus 3 equals 0. So x equals 3. And we have 2x plus 1 equals 0. Subtract the 1 and divide 2. So we get x equals negative 1/2. I have 3 solutions, and what was the degree of my polynomial? 3. If you need to see the X box instead, so the box, remember first term, last term, numbers that you got from the X. And again, it's just GCF, X, negative 3, 2X, positive 1. Same thing that we ended up with, X minus 3 and 2X plus 1. Just whichever one is more appealing to you. All right, so on this example, we're going to do pretty much the same steps. So step 1 is to make sure one side equals 0. So we're going to subtract 6x cubed. And when we subtract, we're left with 3x to the 4 minus 6x cubed plus 12x squared equals 0. Notice I went ahead and wrote it in standard form, which is decreasing power order. Okay. And then step 2, make sure like terms are combined. Like terms are combined. Step 3 is to use our factoring skills. So the first thing I can start with is GCF. I'm going to factor out the GCF. The GCF here numerically is 3, and then exponent variable-wise is x squared. So I factor out 3x squared, and I'm left with x squared minus 2x plus 4 equals 0. Okay, then I continue here, and I now have a quadratic trinomial. I ask myself what multiplies to give me 4, but adds to give me negative 2. I realize, nothing's going to work. When that happens, that means dun, 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 quadratic formula to the rescue. So the quadratic formula comes to the rescue. Quadratic formula is what we're going to use to finish this out. So from this factor, before I go on, I have 3x squared equals 0. I know that that's going to be 1, so we're going to come back to that one. But quadratic formula, x equals negative b plus or minus the square root of b squared minus 4ac divided by 2a. Okay, so for this problem, here's our a, our b, and our c. So we're going to plug them in. So we have x equals, because we're essentially solving at this point. We're no longer just factor, we're solving. So part 4, we have x equals negative b plus or minus the square root of b squared minus 4ac divided by 2a. So that gives us x equals 2 plus or minus the square root of 4 minus 16 divided by 2. So x equals 2 plus or minus the square root of negative 12 divided by 2, which is negative 12. It's going to be 4 times 3, right? So we can factor that out. I'm going to simplify that radical. So we get 2 plus or minus 2i square root of 3 divided by 2. We can simplify. So simplifying, because 2, divide each one by 2. And that leaves us with x equals, so divide by 2, divide by 2, divide by 2. leaves us with 1 plus or minus 1i square root of 3. So our final two solutions are 1 plus I square root of 3, 1 minus I square root of 3. Those are what our x equal. Okay, my other one, so remember this 3x squared right here equals 0. So we have 3x squared equals 0. So x equals 0, and it's with a multiplicity of 2.
Good morning, Waco High.
Okay, so just like I said before, your solutions, your real and imaginary solutions should equal the degree of the polynomial. Degree of our polynomial is 4. I have 2 imaginaries and 1 real with multiplicity of 2. That makes my 4. So I know that I found all my zeros and I'm good to go. All right, our next one, we have x to the 4th minus 3x squared equals 4. Step 1, I'm going to subtract 4, and that's going to leave me with x to the 4th minus 3x squared minus 4 equals 0. This is pretty much a quadratic, okay? So when you see something like this where you have x to the 4th, x squared, and then no power, you should think quadratic, okay? What you do with the quadratic, you're going to do with this quartic, okay? So same thing, factoring wise, I'm going to ask myself what multiplies to give me -4, but adds to give me -3. The only difference, instead of it being just x, it's going to be x squared in my binomials. Okay, so it multiplies to give me -4, but adds to give me -3. That would be -4 and +1. Okay, so now I have my factors. So I'm going to take my factors and set them equal to 0. So x squared minus 4 equals 0. And we have x squared plus 1 equals 0. I add 4. That gives me x squared equals 4. So x equals +2 and -2, because when I take the square root, it produces a positive and a negative. Okay? Here, again, subtract 1. Gives me x squared equals -1. Take the square root. When I'm taking the square root, because it's imaginary, I'm going to have an I. So the square root of 1 is 1. Square root of -1 is 1i. So my solutions are going to be +1i and -1i. Between my real and my imaginary, I have 4 solutions, and the degree of my polynomial was 4. So I know that it is done. All right, example 5, I'd like for you to pause for a moment and attempt example 5 on your own. Okay, well, thank you for pausing. Example 5, the hard work was done for you. It's already factored. So once you're already factored, you are on step 4, where you're taking each factor and set them equal to 0. So you just have to take x squared minus 1, set it equal to 0, and x squared plus 4, and set it equal to 0. I'm going to add 1 to both sides. That gives me x squared equals 1. Take the square root to get x by itself. When you take the square root, you produce a positive and a negative solution. I have plus 4. I'm going to subtract 4 from both sides, leaving with x squared equals -4. Take the square root. That leaves me with x equals, so it's negative, not just 2, but positive 2i and negative 2i. Between my real and my imaginary, there are 4 solutions. And if I was to FOIL this through, I would end up with a 4th degree polynomial. And I have 4 solutions, so I know I did it right. All right, so that concludes us using our factors to solve.